Hello everyone, welcome back to my channel. This is the place where you learn new skill every time you visit. So keep updating yourself by subscribing to the channel.
So this is the second video of the problem solving series, and this time also we are dealing with number problems in Java. Okay, so let's move ahead. First problem in this video is a palindrome number. Now what is a palindrome number? A palindrome number is a number which when you reverse it remains same. For example, the number 1221, when you reverse it, it will remain same as 1221. Alright, so this kind of numbers are called palindrome numbers. Like the another number 1234, when you reverse it, it will be 4321, right? So that won't be a palindrome number. So how do we check and how do we code it? Let's go to the BlueJ and see how we are going to do it. So let me quickly move on to the BlueJ. Here is the BlueJ screen, and I have already made a program. I'll just explain it to you. So here I have asked for a number from user here, and then since over here I have to reverse the number, because reversing is a process which is required for checking palindrome. Now, for example, user has given 1, 2, 3. All right. So when the digit breaking starts in this loop, which we have done in the previous videos, I have explained you in the previous videos. The first number comes out as 3. Okay. Now, if you look at this formula says reverse equals to reverse into 10 plus ditch. So the first value of reverse, the initial value of reverse was 0, right? Which I put it here. Now, as per this formula, reverse into 10, that means 0 into 10, which will be 0, plus the ditch, which came out, which is 3. So 3. So 0 plus 3 is 3. So now reverse is holding 3. Okay. Next time, what is broken out? 2. All right. So now 3 into 10, 30, because the reverse is now 3. So 3 into 10, 30, plus the ditch, which came out just now, 2. So it will be 32. Okay, I'm sure you're getting it. Now reverse is 32, and next time when the loop goes for one more time, reverse into 10, that is 32 into 10 is 320, and 320, and the next digit which came out is 1 plus 1. So it becomes 321. Alright, so now you see 321 is the reverse of 123. So this is the way this loop and this formula is going to reverse a number. Alright, now I'll explain you this. So here we have got a while loop which is running till 1, breaking the number into digit, taking the quotient of that number, putting the reverse formula. Now when the loop ends, you already have a reverse. Now when it is going to be palindrome, when that reverse equals to the particular number. Now why I have not put number here, because if you see here in this example, first the number was 123, right? When 3 came out of it, the number remained 12. When 12 came out of it, the number remained 1. When 1 came out of it, the number which was 123 initially is now become 0. Alright, so number is actual 0. So if I put a number here, if I compare reverse with a number, it's not going to give me the right result. I'll show you that also first, and then I'll do with a copy. Okay, so let me just do it. Let me erase all this. I'll put the number. So let me put it like if reverse equals to number. Okay, I'll compile it. I'll go to the main screen here and run it. So I give 123. Let me give 121, right? So when I give 121, you see Now see, 121 is not a palindrome, whereas 121 is a palindrome. Now the problem is, as I told you, the number itself gets reduced to 0. How will I come to know? How will you agree that what I'm saying is right? So what I'll do, I'll just print the value of number here so that you can yourself see what is the value of the number when the loop ends, when the digit breaking is over. Okay, so here I'm printing it out. So here it goes. 121. You see, number is 0. Do you see that? Number is 0. So since number has become 0, so even though if you have a logical correct statement over here reverse equals to number, it's not going to say it's a palindrome because the number itself contains 0. So now what is the solution of that? The solution is we declare another variable copy, and before we start breaking the number, just after taking the input from user, I should store one copy, one version of one value of that number into copy. So copy contains the number itself. And so when I'm comparing, I won't compare it with reverse, I'll compare it with copy. And then I'll say copy is a palindrome. Okay, else it's not a palindrome. Let me show that now. I shall put a slash in here so that it comes on the new line every time and looks well formatted. Okay, I'll erase the screen. Okay, I kill number 121. Sorry. It didn't work. Let me do it again. Clear, and then I'll compile it again. Okay. Yeah. Here I go. 121. 121 is a palindrome. Number is 0 because we are not comparing with number now. We are comparing it with a copy. Now let me give another number to check, a non-palindrome number. Before that, I'll remove this statement. It's not required now. So now I'll give a number which is not a palindrome, of course. Any other number. One, two, three, four. So reverse is 4, 3, 2, 1. So it's not going to be a palindrome. All right. Let me give another number which will check whether it's a palindrome or not. So I'll run again and give another number. Say 1, 2, 3, 2, 1. Now it is a palindrome because when you reverse it, it still remains the same. Okay. So that was the palindrome number. And let's see what next we have. What is the next problem we have to deal with today? Problem is decirium number. Now what is a decirium number? As per the problem question, the problem is the decirium number problem is a number which when digits are raised to their position, the sum remains same. For example, 135 is the number. If 1 is raised to 1, here 1 is at first position, 3 is at second position, and 5 is at third position. So when the number raised to its position, 1 to 1, 3 to 2, 5 to 3, if you sum it up, it becomes 135. So this kind of number are called decirium number. All right. So again, it's a digit breaking question, but a little tricky because the power is changing. Okay. Now why I said it's a little tricky, because when we break it up, when we break a number, so this number comes out first, the last number. Okay. And if you look at the formula over here, the last number is raised to the power of 3. Now it's not necessary every time it will be raised to the power of 3. It will be raised to the number of digits. Suppose there's a 2-digit number, say 89. All right. So in case of 89, 9 will be raised to the power 2 and 8 will be raised to the power 1, because the number of digit is 2. So the last digit is raised to the power 2 and so on. Similarly, the number of digits is 3. So the 5 is raised to the power 3. So that means what I mean to say is, first job is to find how many digits a number has. Once we get that number of digit, then it is easier for you. So let me go back to the BlueJ and show you there how it works. So the question number 4 here it is. I have already made the format out of it for it. And so first thing, as I told you, our job is to find the number of digits. Now here, instead of taking one copy, I'm taking two copies because one one copy of the number I'll use for counting how many digits and that number has. So once I got the number from user here, I store it into two other variables, copy and copy2. Now I'm using the copy2 here to run a loop and break the digit. Every time a digit is broken, I am increasing the value of the count, so that once this loop ends, the value of the count is number of digits of that number. And since I know, as I gave you an example, like in 153, the last digit broken, 3, will be raised to the power of its length with 3. Okay, so that's why the first position, okay, or I shall call it power, that will be easy for you to understand also, right? So I'll name it as power. Let me do that. I'll name this variable as power. So the first power will be a count, that is 3, and then 5 will be raised to the power 2, and so on. Then 1 will be raised to the power 1, then 5 will be raised to the power 2, and 1 will be raised to the power 1. So that means that power will keep on decreasing, which I will do in the loop. So over here in the loop, again I am breaking the digits, right? And here I am now summing it up. mat.power tich comma POW, because now I change the variable to POW. Now this power I need to decrease because earlier it was power 3. For next time it should be power 2. For next time it should be power 1. Keep on decreasing like that. Okay. Okay. And now once we got the sum, I should check whether the sum is equals to copy, because in 153 when I sum this up, 1 to the power 1 plus 5 to the power 2 plus 3 to the power 3, it adds up to 153. So if that happens to be true, it's a Desarium number, else it's not a Desarium number. Okay, so let's run this and see. Here it goes. Problem 4. 153. 153 is not a Desarium. Okay, 135 is a Desarium. Let me run it again. Oh, 135. So 135 is a Desarium number, as you can see it here. Okay. Now I'll run for one more time and put any number which is not a Desarium, or I'll put a 2-digit Desarium number, which was 89, I believe. So if I type 89, so 89 again is a Desarium number, it says. Now let me put another number which is not a Desarium. Let me put 90. So when I put 90, so it is not a Desarium number. All right. So this is the last problem for this second part of this video. So now we have solved 4 problems on number problems. If you still have more problems on Java number problem, please send it to me. I'll do it. Otherwise, in the next video, we'll be doing something else, some other problem which you would like me to do. So thank you very much for taking out your time to watch the video, and take care. Bye-bye.
If you are new to the channel, please subscribe it. Also press the bell notification so that you get notification as soon as I release a new video. Share and like the video.